Have you ever looked up at the night sky and wondered about those distant points of light? What if I told you that around many of those twinkling stars, there might be other worlds? Worlds that could be just like ours. Today, we're going beyond our solar system to explore these mysterious places called exoplanets. Imagine you're standing on a beach, looking out at the vast ocean. Now, imagine that ocean is the universe, and each wave is a galaxy within it. Floating on those waves are countless tiny boats, each one representing a star. And orbiting around those stars, you guessed it, exoplanets. Exoplanets, or should I say extra-solar planets, are planets that orbit a star outside our own solar system. The term extrasolar literally means beyond the sun, and that's exactly what these planets are. Worlds beyond our sun. It was in 1992 that the first exoplanet was officially discovered. This historic discovery was made by astronomers Alexander Wolfsgazan and Dale Frail, who detected two planets orbiting a pulsar, a rapidly rotating neutron star that emits beams of radiation. Well, since then, the field of exoplanet research has exploded. As of now, we've discovered over 4,000 exoplanets, and that number is growing every day. But not all exoplanets are the same. In fact, they're as diverse as the inhabitants of a cosmic zoo. Well, first up, we have the gas giants. These are the big kids on the block, much larger than Earth, and primarily made up of hydrogen and helium. They're like our neighborhood planets, Jupiter and Saturn. Next, we have the Neptunian planets. These are similar to Neptune in our solar system, smaller than gas giants, but larger than Earth. An interesting thing about them is that they're made up of ices such as water, ammonia, and methane. Moving on, we have the super Earths. These planets are larger than Earth, but smaller than Neptune. They could be rocky like Earth or a mixture of rock and gas. They're like the Goldilocks of exoplanets. Not too big, not too small. Just right. Let's not forget about the terrestrial planets. These are rocky worlds similar in size to Earth or Mars. They're the most exciting for us because they have the potential to host life as we know it. Okay, now that we've met the different types of exoplanets, you might be wondering, how do we even find these distant worlds? Well, it's not like we can just hop on a spaceship and go visit them. Not yet, anyway. Instead, we use a variety of ingenious methods to detect and study exoplanets from right here on Earth. One of the most successful techniques is the transit method. This involves observing a star's brightness for a prolonged period. If the star's light dims at regular intervals, it could be a sign of a planet passing in front of it. It's like playing cosmic peekaboo. Another method is the radial velocity or wobble method. This involves observing the small wobble in a star's position caused by the gravitational pull of an orbiting planet. It's a bit like watching a parent being tugged back and forth by their child on a swing. These methods, along with others, have allowed us to discover and study thousands of exoplanets. But the real question on everyone's mind is, are there other planets out there like Earth? The answer is yes. Scientists have discovered several exoplanets in the habitable zones, also known as the Goldilocks zone. This is the region around a star where conditions might be just right for liquid water to exist on the surface. Not too hot, not too cold, but just right, like we discussed earlier in the video. But why is liquid water so important? Well, as far as we know, water is essential for life as we know it. It's the cosmic soup where all the ingredients for life mix together. So finding a planet in the habitable zone is a big deal because it could potentially host life. One of the most famous is Proxima Centauri b, which orbits the closest star to our sun. It's a little more massive than Earth and sits right in the habitable zone of its star. Another exciting find is the TRAPPIST-1 system, which has not one, but 7 Earth-sized planets, 3 of which are in the habitable zone. But still, just because a planet is in the habitable zone doesn't guarantee it's habitable. There are many other factors to consider, like the planet's atmosphere, magnetic field, and more. So what does the future hold for our exploration of these distant worlds? We're not stopping at just finding these exoplanets. The next big step is to study them in more detail. We want to know what their atmospheres are made of, what their surfaces look like, and most importantly, whether they could support life. To do this, we're developing new technologies and missions. One of the most exciting is the James Webb Space Telescope. This incredible piece of technology will be able to study exoplanets in ways we've never been able to before, looking at their atmospheres and even searching for signs of life. Future missions, like the Habitable Exoplanet Observatory HABEX and the Large UV Optical Ire Surveyor LUVOIR, aim to directly image Earth-like exoplanets. That's right, we might actually get to see what these distant worlds look like. And how can we forget about interstellar travel? While we're not quite ready to pack our bags for Proxima Centauri b, scientists are already working on concepts for spacecraft that could make the journey to other stars. Projects like Breakthrough Starshot are exploring the possibility of sending tiny, light-powered spacecraft on a one-way trip to our nearest stellar neighbors. That's it for today. From gas giants to rocky Earth-like planets, we've seen it all. And the best part? Well, let's say this is just the beginning. With new technologies and missions on the horizon, who knows what we'll discover next. Now, we'd love to hear from you. What do you think about these distant worlds? Do you believe there's life out there? And if you had the chance, would you pack your bags and set off for an exoplanet adventure? If you enjoyed this video, don't forget to like, share, and subscribe for more space content. As always, thanks for watching.